scaling fractions. Scaling fractions. Should I just stop singing? I think I hear you say yes, please. Okay, so let's just get to business. So scaling fraction simply means lifting that fraction or squeezing it. So we say scaling up by a factor. It means that we are multiplying this fraction by a factor. Double it, triple it. Okay, so if I scale this fraction by 2, scaling this fraction by 2, which means I'll multiply both the numerator and the denominator. I'm not saying increase it by 2. That means you can maybe add 2 to it. I'm saying scale it up, right? Multiply it, right? Double it. That's what multiplying by 2 means. So we have 3 times 2 gives us 6. And 10 times 2 gives us 20. We're only scaling it up. When you look at it in real terms, the value will still be the same, but we are scaling it up. Okay? So we have another one. Let me multiply by 2. You can keep scaling. This will give me 12, and this gives me 24. This comes in very handy in the kitchen or when you are building. For instance, if I use 2 cups of flour for a big cake, if I need 2 cakes, how many cups of flour would I use? Right? I'll scale that up by 2. That's what it means. So scaling up by a factor means you're multiplying it by a factor. So let's scale this up by a factor. This time around, should we scale it up by 3? Yes, let's keep scaling it up by 3. So I have 2 times 3 gives me 6. And then this will be 9. This multiplied by 3 gives me 18. And this gives me 27. I can keep scaling it as much as I want. Just like saying multiples of fraction, right? Multiply it by a factor. So let's scale this again by another 3. Should we? No, let's not do that. Now let's look at another example. This time around, we are going to scale down. And that's what we do actually by simplifying. So I'm scaling it down, which means I'm dividing by a factor. So let's divide this by 2. With our 4 divided by 2 gives us 2. 6 divided by 2 gives us 3. Okay, we can keep doing this and keep dividing or scaling the fraction down by a particular factor, and it gives us different equivalent fractions because they will have the same value. It's just that looking at them, they have different numbers, right? So scaling down by a factor, let me see what I can use to scale this down. 11 and 33. What common factor do we have? It has to be 3. That's what we do with simplifying, like I said. So I scale this divided by 3. Oh, sorry. It has to be 11. It has to be 11. 11 cannot be divided by 3. 11 is a prime number. So it has to be 11. So I scale this down by 11. I have 1. And 33 divided by 11 gives me what? 3. So 11 over 33 simplified or scaled down by a factor of 11. I have 1 over 3. So scaling down and scaling up fractions will come in handy when we learn about equivalent fractions or when we start comparing fractions. Okay? So what have we learned today? Whenever you are scaling down or up a fraction, both of them, the numerator and the denominator, must be scaled. No cheating. Can you say that? No cheating. You don't cheat any one of them. So you multiply both the numerator and the denominator, or divide both the numerator and the denominator. Remember, you can do whatever you put your mind to do. Oh, I'll stop singing. See you some other time.